This is the method I saw a couple of students using when I did the activity with year 7. They started measuring the distance between the 2 points, the most direct route via a straight line, found the midpoint and used that as their centre of rotation. And effectively they're doing the centre of the circle, 2 radiuses the same. We discussed that in class, and we also discussed the fact that for this going to Japan to Birkenhead, 3 students had got 3 different answers, different centres of rotation, different angles, but they all worked. Why was that? I used this to present to the year 10 higher class as an introduction again to rotations, and said, okay, year 7 found these 3 solutions. Is there a method for finding them? Are there more solutions, and how would you do it? And obviously you need to be ready to guide and help to varying degrees depending on which student you're talking to. But eventually we got to, okay, yeah, the key thing is just that this compass, provided I set it over to halfway, and that was a big long discussion, was there some solutions that just wouldn't work. So we set it to just over halfway, and then I can draw it from one end, take the compass away, go to the other point that I've come from, and draw the arc there. And sure enough, where they cross every time will be a centre of rotation. And I can produce lots, I can just make lots like that, provided that my compass is always over half the distance. If it's less than half the distance, so anywhere over half the distance, that's about half the distance between the Japan and Birkenhead crosses, I'll get a solution. I draw an arc here, I do the same on the other side, and sure enough, I'll get a solution further around, up about here somewhere. However, if it's less than halfway, you won't get a solution, and again you have a good discussion about why is that true. They experiment and convince themselves that it is true, and of course, because from this side they'll never reach, there won't be a centre of rotation on that arc that will work. And then you can take that a step further. So let's just get rid of the ruler so we can see a bit more clearly. Is there a way we can calculate the angle? So now we've got the way of finding different centres. Is there a way we can calculate the angle? And you can start having that lovely discussion about that centre of rotation, this centre of rotation, that centre of rotation being a smaller and a bigger circle, and therefore the arc length, and therefore how can we, using the arc length, using the radius, find the arc length, and using that find the angle. And it just begins a nice introduction into arc lengths and sectors. So really rich activity.